Hi Year 11 and welcome to this video which is going to look at concentration calculations, how to do them, what concentration is, if you have to, for example, do a conversion. What I'm hoping you notice is it's actually primarily a higher tier only content, but there is a little bit where the foundation tier students also need to know about it. So we're going to look at concentration calculations. We're going to look also at gases and how to do the calculation that usually comes up as gases, and then we're going to do some examples of those as well. So we'll start by getting you to have a think about what concentration is. So what I will point out about concentration is you will already know it from the rates of reaction, which is paper 2. Because we do talk about what concentration is and how actually a higher concentration speeds up the rate of reaction. We do, for higher tier, need to know the difference between the strength of an acid and the concentration of an acid. So make sure you've watched the video on that if you're not sure what that means. But essentially, concentration is a measure of how crowded things are. And when you've got a specific amount of a substance, so let's imagine we've got salt, for example, dissolved in water. The amount of a substance that is dissolved in a specific volume is how we are measuring concentration. So the more substance you have, the higher the concentration. Less substance, the lower the concentration. So essentially what I'm saying is more solute, which is the solid I'm adding to the solution, the higher the concentration. Now, you are expected to be able to describe how to do or use, should I say, the concentration calculation in two ways. One way is through the titration required practical, and the other is through looking at reacting masses. And what I want to start off with first of all is concentration when we're talking about it in the terms of mass. So how do I know this is in mass? Because it's got grams there. So I know it's got to do with the mass of something. It might be the mass of a specific solid that I've added that they've given me as part of the question. And I know that decimeters cubed is a volume. And that's what concentration basically is. So it's grams per decimeters cubed. So just to remind you about conversions, sometimes they give you the volumes in centimeters cubed. To convert it into decimeters cubed, we essentially divide by 1000. So just keep that in the back of your heads. And you can see I've got my triangle here with my calculation, which is mass, concentration, and volume. Can we rearrange it? Okay, so let's rearrange the calculation. So if I'm being asked to work out the mass of a substance within a specific concentration, then I would do concentration times volume. If I'm being asked to work out the concentration, which is often the one you are asked, then you would do mass divided by volume. And the final one is volume, which would be mass divided by concentration. Now, mass comes up on other places. So if you remember, moles, for example, equals mass over mR. So you might be given these two things here. You have to work out what the mass is, and then you might have to fill in or calculate the concentration of a substance. So just be mindful, you can in fact pull in other calculations into this specific triangle. Okay, so let's move on because I want to actually look at practicing using this calculation. So what I'd suggest you do is I'd suggest you stop the video here, pause it, give the calculations a go. I've given you some exam questions as well. And then we will go through the video, and again we're going to be using this calculation here to complete the activities. Always check your units. Right, so hopefully you've done that. So let's go through this here then. So you can see I'm being asked to calculate the concentration. When I do that by taking the mass of the substance and dividing it by the volume. Now it's given me the mass because that there is my mass value, and it's given me the volume, and I'm going to tick it off because it is in the right units. So essentially all I'm going to do for this table is take the mass and divide it by its volume. So 50 divided by 20 would give me 2.5. 18 divided by 90 would give me 0.2. Then I've got 65 divided by 780, 0.083. 98 divided by 132 should be 0.74, and 700 divided by 1050, 0.64. Okay, so that's just practicing the calculation. It's not often how the question will in fact come up. That's why I've given you some exam questions to look at the types of questions you might get asked around this. So I can see that this has got to do with mass. So when I think of mass, I think of two equations. I think of moles equals mass over mR, and I think of concentration equals mass over volume. Okay, so they're the two calculations that we teach you that have got the value of mass. So again, that's the prompt. The grams helps me figure out where I should in fact, or which calculation I should in fact be using. So 30 grams of sodium chloride is dissolved in 0.2 decimeters cubed. I'm checking the units is in the right units. I know that's a volume, so straight away I can rule out that equation. I'm going to be using this one. It's asking me what is the concentration of the solution. So concentration, as you know from the triangle, is mass divided by volume. I have the mass from the question, which is 30 grams. The volume units is in the correct units, so I'm dividing it by 0.2, and that would therefore equal 150. Now again, I want to put the units for concentration in this case, which would be grams per decimeters cubed. Okay, so that's an example question there. Let's try some more. Again, I've got to check my units because with every chemistry calculation, I have to make sure I've got things in the right place. So 15 grams of salt is dissolved in 300 centimeters cubed of water. What is the concentration? I can see that that is in the wrong units because it should be in decimeters. To convert centimeters into decimeters, I divide it by 1000. So that means to do the concentration, I'm going to do mass over volume. The mass is 15 grams, and the concentration, once it's divided by 1000, would be 0.3, and that gives me a concentration value of 50 grams per decimeters cubed. Okay. Next, a solution of magnesium chloride has a concentration of 24 grams per decimeters cubed. What is the mass? So this time I'm going to have to rearrange the equation. So I know that mass is at the top, concentration and volume. It's asking me to calculate mass. So to do that, I would do concentration times by volume. So mass concentration is 24 grams per decimeters cubed, and I can see that in the question. And yes, the volume's in the right units, so I keep that as it is. So essentially I'm doing 24 times by 0.4, which would give me a mass value of 9.6 grams. Okay, so hopefully you've got the same thing as I got. As you can see, I've laid it out to show the working because it is important you show the working. So I want to essentially show you an exam type question on this. So I'm going to just jump ahead to where we've got this question here. So as you can see, it's worth 3 marks. This is a typical question that involves the use of the calculation we've just practiced. So it says a solution of hydrochloric acid contains 3.2 grams. So again, that's my cue. This is a mass question. So I've got to think about my equations that involve mass. So I know that that is moles equals mass over mR, or it's concentration equals mass over volume. So I know they're the only two equations that involve the mass number. So I've got the solution of hydrochloric acid contains 3.2 grams of hydrogen chloride in 50 centimeters cubed. Check my units. I can see straight away that's not in the right units. So I have to divide that by 1000 to get it into decimeters cubed. And it's asking me to calculate the concentration of hydrogen chloride in grams per decimeters cubed. So to do that, concentration equals mass divided by volume. Mass is correct, so 3.2, and I'm then dividing it by the volume, but the volume has to be in decimeters cubed. So I'd have to convert that by dividing 50 by 1,000. So that's going to give me 0.05 decimeters cubed. And then that's going to give me my answer, which would be 64 grams per decimeters cubed. Now, it doesn't seem very complicated, but you've got a lot to think about for this question, which is why it's worth 3 marks. You need to remember the equation, okay? You need to remember the conversion, and then you need to be able to do the calculation. So make sure you show you're working out, as I've always said. So that's the first calculation around concentration, where we're looking at mass and volume. We're now going to spend a little bit of time looking at concentration from the point of view of titrations. I do want to point out this is for higher tier only. And what I've done is I've actually given you an example of the triangle that you need to know. So as you can see, I've got moles, volume, which is always in decimeters cubed, and concentration in moles per decimeters cubed. So remember, concentration can only ever be in grams per decimeters cubed or moles per decimeters cubed. The grams one is the mass one, and the moles one is usually the titration one, okay? But it is important you're aware they're the only 2 units that we use for concentration. So I'm going to get you to rearrange this triangle to make sure you're clear on how to do it. So if I'm asked to work out moles, that is going to be concentration times my volume. But I've got to make sure my volume is in decimeters cubed. So sometimes you have to divide it by 1,000, as you've seen before. That's often what comes up. If I'm being asked to calculate concentration, then that would be moles divided by volume in decimeters cubed. And if I'm being asked to work out the volume, then that would be moles divided by concentration. So if you've watched the video on titration calculations on strong and weak acids, we have practiced this calculation quite a lot. But again, I've got some examples for you to look at. So it says, what's the concentration in moles per decimeters cubed of a solution with 2 moles of salt in 500 centimeters cubed of water? So I'm being asked to calculate concentration, which if I look at my triangle is moles divided by volume. My mole value is 2. My volume value, though, I've got to divide it by 1,000 because it's not in decimeters cubed. So I divide that by 1,000, and that would give me 0.5, which is then going to give me a concentration of 4 moles per decimeters cubed. Okay. Now, when it comes to titration questions, though, it's a little bit more complicated, and I'm going to show you that on the next page. But often you find that you're asked to convert from moles per decimeters cubed into grams per decimeters cubed. And for some reason, students find that a little bit tricky. But essentially, all you're doing when you're converting moles per decimeters cubed into grams per decimeters cubed, so think about this logically, that's a volume, that's a volume, that's a mass, okay, this is moles. So actually, if I was wanting to convert moles per decimeters cubed into grams per decimeters cubed, all I would have to do is times the concentration I've calculated in moles per decimeters cubed by the MR of the substance. Now, where would I work out the MR of a substance? Well, often you're given a formula. Okay, you'll be given a formula for a specific substance. It might be sulfuric acid, it might be hydrochloric acid, it might be sodium hydroxide. Whatever it is, they will give you the formula. And then within the question, you will see it has the formula masses from the periodic table. But if it doesn't have that, you have got it from the periodic table. So remember, this is about 1 mole of a substance. So all you have to do is times it by the MR to convert it into grams. And I'm going to show you an example of that now. So here's your classic calculation question that involves concentration. It says, and we'll go through it and I'll show you how I'd lay this out. So it says the student repeated the investigation. The student used solutions that had different concentrations from the first investigation. The student found that 15.5 centimeters cubed of 0.5 moles per decimeters cubed sulfuric acid completely reacted with 25 centimeters cubed of potassium hydroxide. And here's the equation. So I can see that there's a 2-to-1 ratio there. for the reaction, and it makes salt plus water. So it's asking me to calculate the concentration of potassium hydroxide in moles per decimeters cubed. So I know, because I've already written down the calculation around this, moles, concentration, volume. Okay, but when we do the titration calculation lesson, I've taught you a really silly mnemonic to remember what you have to write down. So you'll know that it's cats, and I'm going to write it down the side. Cats violently murder rats. Okay, so that is concentration, volume, moles, ratio. So that's my tick list of things I've got to make sure I write down. It says that you're looking at sulfuric acid and potassium hydroxide from the question. So there's potassium hydroxide and there is sulfuric acid. So now I'm going to use a question to fill in my table. Volume. The student found that 15.5 centimetres cubed of 0.5 concentration of sulfuric acid. So I'm going to start with my sulfuric acid. Do I have a concentration? Yes, I do. I get that from the question. Do I have a volume? Yes, I do. So 15.5, but I've noticed straight away it's not in the right units. So I have to divide that by 1,000. Okay, so 15.5 divided by 1,000 is going to give me, so divided by 1,000 will give me a number of 0.0155. And it then says from the question that sulfuric acid reacted with 25 centimetres cubed of potassium hydroxide. So I don't have a concentration for potassium hydroxide because the question is actually asking me to calculate it. I do have a volume though, which is 25. Again, I'm dividing it by 1,000 because the units are not correct. So that's going to give me a volume of 0.025. Now I move on to the next thing. I've got to calculate the moles. So from the equation, to do moles, I do concentration times by volume. Now look at potassium hydroxide. I've only got a volume, so therefore I can't work out the moles for that. Over here, I've got my concentration and I've got my volume. So I'm going to do 0.500 times by 0.0155. And that's going to give me a value of 0.00775, I think, is what it gives me. So that's my moles. Now I go down to ratio in order to work out the moles of potassium hydroxide. To work out the ratio, I have to use the original equation. So I can see that there's 2 potassium hydroxides for every 1 sulfuric acid. So if that's the moles for sulfuric acid, I'd have to times that by 2 in order to work out the moles for potassium hydroxide, which times it by 2 gives you 0.155. So now I've got my moles and I've got my volume. So therefore I can calculate concentration. So to do that, I'm going to do 0.0155. I'm going to divide it by 0.025. And that's going to give me an answer of 0.62 moles per decimeters cubed. So there's my answer for the first part. It then says that I have to convert that into grams per decimeters cubed. And that is using potassium hydroxide, which formula is here. So I can see that K equals 39 from the periodic table, O is 16, and there's 1 hydrogen in potassium hydroxide, so that's the formula there, equals 1. So I just add all those up together, and that should give me 56. So I then times that by 56 because that's how you convert it into grams per decimeters cubed. And that gives me a concentration in grams per decimeters cubed of 34.72. So lots to do there, lots of things to think about, but hopefully that's showing you how these 2 concentrations do in fact link together. Okay, the last calculation I want to look at with you is volumes of gases and making sure that you're clear on the calculation and what it essentially is used for. So this has always got to do with reactions that involve just gases. And how will you know that? from the question? Well, you might know it from the equation, okay, because they'll give you the states of the substances, which you know if it's a gas, it should be G. Or the hint is normally they give you the number 24 decimeters cubed at room temperature and pressure, because that's the hint that this is to do with the calculation that comes from looking at gases and solutions. So why do we have this number in the first place, which is 24 decimeters cubed? Well, it's kind of like Avogadro's constant. You know, when we said Avogadro's constant is a fixed value that we assign to a specific number of atoms in 1 mole of a substance. When we have 1 mole of a gas, we should therefore know that it will occupy a fixed volume of 24 decimeters cubed, okay? And that's at room temperature and pressure. And I'm sorry, guys, you need to know that. What does it actually mean, though? So if I'm thinking this like an equation, so if I've got the Haber process calculation, which looks like this, okay, this is paper 2, remember, but these are all gases, and I know that because they'll have the symbol next to them. And the question was asking me, let's imagine it says, well, what would the volume of hydrogen be for this reaction? Okay, I'm making this up. So if I know that 1 mole of a substance occupies 24 decimeters cubed, then actually I'm looking at how many moles of each thing I've got in my reaction. So nitrogen, for example, I've got 1 mole because there's no number in front of that. So I know I must have 24 decimeters cubed of that gas. Hydrogen, I've got 3 moles of hydrogen there. So I would do 3 times by 24, which is going to give me a volume of 72 decimeters cubed. And ammonia, I've got 2. So I do 2 times 24, which I know is going to be 48 decimeters cubed. And that's all because of that statement there. 1 mole of any gas will always occupy 24 decimeters cubed. So if I know how many moles of a gas I have, I can therefore work out the volume. And that's where it leads into a calculation that you need to be aware of and need to be able to write down essentially. So we're going to turn over because here is the calculation. And I want to just really put a box around this because this is the calculation that you do need to know. Where you can see it says volume in decimeters cubed divided by 24, because we know that is the volume that 1 mole of a gas will take up. And I've got moles here. Now moles, we should know, we can calculate moles from mass divided by MR, which is why I've got this calculation up here, because really what I'm saying is the volume of any gas can be calculated by the mass of the gas divided by the MR of the gas. Now the MR is what you get from the periodic table. The mass is usually from the question. And I've got to remember that 1 mole of every substance has got a volume of 24. So I can therefore calculate the volume if I needed to. So let's look at a question on this. It says, what is the volume of 319 grams of chlorine at room temperature and pressure? So that's my prompt to remember the number 24, and it has to be in decimeters cubed. Chlorine is a non-metal, so we know that chlorine is therefore diatomic, always comes in pairs, so that's its formula. And I've got a mass here. So in order for me to calculate the volume, I have to first of all calculate the moles. So moles is equal to mass, which is 319.5, divided by the MR of chlorine. Now, I have to use the periodic table for this. So on the periodic table, it says the mass of 1 chlorine atom is 35.5. The formula of chlorine is Cl2, as you can see there, for 1 mole of it. So I'm timesing that by 2 to get the MR value for the bottom part of my calculation. So that gives me my moles. That will give me my moles value. And then I'm timesing that by 24 to then get my volume. Okay, so I should, in theory, therefore, work out 108 decimeters cubed because everything's staying in decimeters cubed. So I think the best thing to do is look at an actual exam question on this, because I think that's the best way to practice these questions. So it says, calculate the volume of 150 kilograms. That doesn't look right to me because I'm pretty sure everything we've talked about is in grams. Of chlorine, so chlorine we know is Cl2, it also tells me that down there. At room temperature and pressure, so that's why the number 24 is there. So volume, as you know from the calculation, is moles times by 24. In order to work out moles, I would do the mass divided by the MR. The mass, though, is not in the right units because it's in kilograms. I've got to convert that to grams. So that would be timesing it by 1,000. So that's going to give me a ridiculously large number of 150,000. I divide it by the MR, which is given to me in the question, which I know is 71 because there's 2 chlorine atoms. And then I times it by 24 because that's the volume any 1 mole of a gas will take up. And that's going to give me an answer of 50,700 decimeters cubed. Okay, so lots to think about in that question there. We'll look at one more, and then again, you can go on to practice these. So here's a 3-mark question. Lots to think about here. So it says, iron chloride is produced by heating iron in chlorine gas. So I've got 2 moles of iron for 3 moles of chlorine, makes 2 moles of iron chloride. It's asking me to calculate the volume of chlorine needed to react with 14 grams of iron. And it's actually told me all the things that I need to make sure I do. So I've got to do the number of moles of iron that I've used. I've got to do the number of moles of chlorine that will react with 14 grams. The volume of chlorine that is needed, because that's essentially what I'm going to be asked to calculate. And it's given me the mass of iron. So that must be important. And it's told me that the volume of 1 mole of any gas is 24 centimeters cubed. So I've got lots of calculations I've got to remember. So moles is mass over MR, because I'm going to need that because I've got mass in here. There's my grams. And I've also got to remember that volume is moles times by 24, which is the volume of 1 mole of any gas. So let's see, first of all, where I've got to work this out from. So I can see I've got the mass of iron and I've got the MR of iron. So let's do that bit first. So moles equals the mass of iron, which is 14. And I'm dividing it by the formula mass of iron, which is going to give me a moles value of 0.25 for my iron. Okay, so I can see that I've got 0.25 moles of iron, but we want to make sure we can work out the ratio for that specific moles value. So, because I'm being asked to calculate the volume of chlorine. So the ratio is 2 to 3. So essentially, if I wanted to work out what 3 moles of that substance would be, then I would in fact times that by 3 because I've worked out that's for 1 mole. So 0.25 times by 3 is going to give me 0.75. So that's the mole value for my chlorine. So I've already worked that out. I then pull that into this calculation, which is moles times by 24. So 0.75 times by 24 is going to give me a value, if I can get a calculator on the go. .75 times by 24 gives me a value of 18. Now, chlorine is a diatomic molecule. It comes in pairs. So I've got to do this for 1 mole of a gas. So I've got to make sure I then work this out for 1 atom. So I divide that by 2, and that is then going to give me a volume of 9